Welcome. Looks like we've got a great crowd here today. Thank you all so much for being here. I'm Nick Erickson, your host for this webinar, and this is episode 6 of our weekly webinar series. 2 weeks ago, we had one of our biggest webinars to date when we introduced our all-new 6800 series universal testing systems. That webinar is now available on our YouTube channel in case you missed it. Today, I'm joined by Kayla Thackeray, who's here to share some tips and tricks for increasing testing throughput and lowering variation on your lab's electromechanical universal testing systems. Kayla has been in the materials testing industry for 7 years, and a few of you may even know her if you've recently worked on any customer-backed innovation projects with Instron. Kayla is also a wealth of knowledge when it comes to grips and fixtures, as she is responsible for a large percentage of those items that you can find in our accessory catalog. We're also joined by Dan Caesar, one of our application engineers. He's going to keep an eye on questions while Kayla is presenting. Please feel free to type those questions into chat as we go along. Dan and Kayla will do their best at the end to address live questions along with questions we received when you registered. One quick note about Kayla's microphone, it may be a bit on the quiet side, so you might just want to turn up your volume a bit in a second. With that said, I'm going to turn things over to Kayla now.
Thanks, Nick. I'm excited to talk to you about this topic today, so thank you for joining in. Today we will start by talking about variability. It is important to receive consistent and reliable results from your testing system, so we will talk about the factors that can influence your results and how you can mitigate them. Then we will talk about ways to increase your laboratory's throughput and get your results faster. To some, it may seem like these two topics might oppose one another, but many of Instron's hardware and software solutions actually help move the needle for both. No matter how closely you follow a testing standard, such as an ASTM or ISO, you may see variability in your results. This is a list of some of the factors that can influence results. This is by no means a comprehensive list, but this includes most of the common ones we see. The ones indicated by a blue dot are by far the most common we see when we visit customer labs. These include specimen alignment, type of extensometer, extensometer attachment, and method setup. The first is specimen alignment. We did an internal study where we took a series of different polymers listed at the bottom of this slide. First, we ensured that every specimen was installed perfectly, and on the top graph you can see very consistent data. In the graph below, the specimens were not properly aligned. You can see there's more variation in the testing results, such as modulus and an overall lower yield stress. It can be difficult to align your specimen by eye perfectly every time, but the good news is that there's an easy fix. We have two suggestions to ease specimen alignment. First, by implementing specimen alignment devices. These are shown on the right side of this slide. These are available for our newer style side action grips and wedge grips. They attach directly to the back of the grip and are highly adjustable for many different specimen geometries. This is a minor add-on that will benefit you in two ways. It will decrease variability as well as save time because it's easier to push the specimen against the stops. Our second suggestion is to use jaw faces that have the same width as your specimen at the gripping portion. This will help the operator align the specimen by eye compared to the edges of the jaw faces. Another factor that can lead to variability is extensometer placement or attachment. We did another in-house study to analyze the factors associated with extensometer placement and attachment. What happens if you place your extensometer a little too high, a little too low, or at an angle? In the first graph, we used an automatic extensometer to ensure it was attached in a very repeatable way. In this case, we used the Auto X. As a result, we were able to get very consistent modulus data, which you can see by the very tightly grouped modulus lines. Then we ran a study using a clip-on and intentionally attached it at an angle. As you can see, with a poorly attached clip-on, you can expect more variability in modulus data and inconsistencies in your break locations. Just to be clear, I'm not saying that clip-ons by any means are bad, They're extremely accurate and when used appropriately produce highly repeatable and reliable results. What this study does show is that they're more susceptible to being misused, which can result in unwanted data variation. Now we'll move on to the method setup. The first tip we'll talk about is choice inputs. If there's a discrete number of answers to a particular question, such as your dumbbell type or operator, the potential options can be pre-programmed in and the operator can choose from a drop-down list. This is one of my favorite features to use as it dramatically cuts down on spelling mistakes and incorrect inputs, making it easier to analyze the data after the test. Not to mention it's much quicker to select something from a drop-down rather than to type it in. Building off of choice inputs, next we'll talk about linked values. Like choice inputs, this feature can reduce the number of methods required for your lab and minimize the potential for operator errors. A linked value is a testing parameter that is linked to a choice input. In this example, we have 5 different specimen types, and each specimen type calls for a different testing machine rate. The screenshot at the top shows how to set this up in the method, and the screenshot down below shows what the operator would see. By selecting a specimen type, the rate, which you can see is grayed out, will automatically change based on the table that was set up in the method. Machine compliance is specific to each system setup and is dependent on the forces a given system is subjected to. When a system is under test and applying a force, there's a deflection from the load cell, the crosshead and base, the lead screws and drive system, and the grips and adapters. The displacement measurement is based off of an encoder that is attached to the motor, so all of these variables can add on to these displacement readings. This is a major reason why extensometers are used, to measure strain directly from the specimen. But when that's not possible, you can also use a virtual measurement in Bluehill Universal called corrected displacement, which removes the system's compliance from the displacement measurement. It's important to understand that changing any component of a test setup will change the system's compliance. Different capacity load cells or utilizing different grips or fixtures will contribute different deflections. We have a white paper with more information and instructions on how to set this up in Bluehill Universal, which I'll provide as a handout for this webinar, and you can also find it on our website by searching for compliance correction. So how do you deal with the factors that affect repeatability? The items that we discuss, plus a few additions, are shown on this cost versus impact chart. This, of course, is not a linear or two-scale graph, but you can see specimen alignment solutions first, along with Bluehill Universal for the method setup impact. Next is utilizing an automatic extensometer, which is more of an investment but makes a greater impact. Finally, we have our automation solutions, either a non-robotic AT3 or the robotic AT6. These solutions will remove all human factors from the testing, which will greatly impact your repeatability. Some research and development labs that I have visited utilize the AT6 to cut out human error and really focus in on the changes in material properties due to changing the formulations. Next, we'll move on to laboratory efficiencies and how you can obtain your results faster. To demonstrate the impact certain setups can have, we completed a case study comparing 2 typical systems set up for ISO 527-2. The question we sought to answer in the study was how much time can be saved if we use the same testing frame and same exact material, but varied the measurement device, grips, and extensometers used. Here are the 2 setups we use. The first one is more basic and a manual system. In this scenario, the setup includes manual wedge grips, a clip-on extensometer, and a micrometer that is not integrated with the software. This was compared to the ideal setup, which includes pneumatic grips with specimen stops, an automatic extensometer, and a micrometer integrated with the software. Before we get into this, let's talk a little bit about the formula behind cycle times. Out of all of the parameters associated with a tensile test, the one that we cannot improve upon or change is the actual test time. This is shown in orange here. As per the standards, you are required to run at a specific rate, and the time it would take to break at this rate is dependent on the material being tested. The only way to improve on your cycle time by focusing on the test time is to use a multi-station testing system, which uses 3 to 5 load strings between the same frame. This enables you to run 3 or 5 specimens during one test time, which helps increase your throughput. But for this test, for this case study, we focused on a normal testing machine with one load string. There are a lot of areas where you can improve your cycle time, which are shown in blue here. In this case study, the test time was approximately 1 minute. When compared against each other, the system setup on the right showed a 38% reduction in cycle time, which is equal to 80 seconds saved. If you need to test 100 specimens during a shift, the setup on the right can save 133 minutes of time. For more brittle materials, or if you're able to run faster test times for your standard, you can see over a 50% reduction in cycle time with the ideal system setup. A video of this study is shown on our YouTube channel if you'd like to take a deeper look. It shows an operator running a specimen from start to finish with the basic and also the ideal setup, so that you have an idea of how much time this could save. Bluehill Universal has so many features that can be utilized to save time and minimize errors. We have many software videos online that talk about some of these features, but I wanted to highlight these 4. When I've visited customer laboratories, these are the 4 features that I find myself talking about the most often. When talking about cycle times and minimizing retests, these 4 features can make a big difference. First up is prompted tests.
In some cases, users may want guidance for running a test, or lab managers may want to follow a specific procedure to prevent operator error. A prompted test can be configured by going into the Method tab and turning on Prompted Test. By enabling Prompted Test, a user can create a workflow that the system operator must follow until finishing testing. Here is a list of some of the options that can be configured as part of Prompted Test. Create a sequence. Here you would define parameters such as required number of specimens to be tested and the necessary steps in the workflow. Start sample. This is where the operator would enter information before starting a new sample, such as lot number or lab conditions. Before test is where users would enter information like specimen dimensions, specimen ID, and instructions for properly placing the specimen in the load string. Additionally, you can add a picture file to visually guide users on proper test setup, preventing issues such as specimen misalignment. Before analysis is used when calculations require information from the operator, such as using the cursor select to identify points on the graph or the failure mode of the specimen. Test notes is where the operator could add any additional notes about the test. The finish prompt automatically appears when the required number of specimens are tested. It will prompt the user to add any additional information about the sample or alter export settings such as folder location and file name. Now let's go through to view what the operator would see during a test. Prompted test is ideal for quality control professionals who are responsible for collecting accurate and reproducible data and results. Prompted test can offer peace of mind for a lab manager, as it can reduce human error and ensure all data is collected in a consistent manner.
ASMD is one of my favorite features. In some cases, specimen measurement can consume 50% of your cycle time and easily provide areas for input errors. These dimensions are critical for accurate stress and modulus results because this provides the cross-sectional area of your specimen. In this example, 3 readings across the width and 3 readings across the thickness are taken of the specimen. You can either use the button on the side of the micrometer or caliper to transmit each dimension, or use the foot pedal. The software is very easy to set up and can be configured for use with width only, thickness only, or both. You can also specify the number of readings required and if it should be reported as an average, minimum, maximum, or median. These requirements are dictated by the testing standard. Next is a video on setting up PassFail Criteria. This is especially useful for quality control laboratories.
The PassFail module in Bluehill Universal allows users to add a test component to the workspace to quickly visualize if a test passed or failed based on the acceptance criteria set in the test method. Here is a sample file for tensile test of plastic specimens in a quality control setting. Quality control testing requires specimens to remain in a specified tolerance for either all or certain results, including modulus, tensile strength, strain at break, among others. Within the Method tab, under the Workspace section and Results subsection, the acceptance range can be set for each individual result. The upper and lower bounds can be manually set or utilize number inputs. This is helpful when utilizing choice inputs and linked values, allowing a user to automatically have the software set the boundaries based on the specimen information. The user can toggle whether they want the criteria to be measured against each individual specimen or the sample as a whole. Now, navigating back to the Test tab, we can see Bluehill Universal added indicators of whether a specimen was within specifications or not. These visual indicators can sometimes be missed by an operator, resulting in required retests and manufacturing downtime, costing a company time and money. Editing the layout of the test screen, we can place the PassFail module wherever is convenient for the operator. Once the PassFail module is enabled, it provides a clear, unmistakable visual indicator of the test status. This allows for quick recognition of out-of-specification materials and products. Within the Method tab and in the Workspace subsection, there is a PassFail menu. Here the verbiage can be changed for either a pass or fail description. A fail notification could alert the operator to seek the assistance of the lab manager. Additionally, by clicking the information icon in the PassFail module, the operator can see specifically why the specimen failed. PassFail in Bluehill Universal is intended to simplify the quality control workflow, minimizing errors and maximizing confidence in the data.
Finally, I'll show you a video on our exporting features in the software. In the labs I've visited, exporting the results can be a pain. The time it takes to export the results into the format or the system that you require can likely be cut down dramatically by utilizing these features.
Customizable exports. In Bluehill Universal, users can customize export information to include test results, method parameters, and raw data. Here we have a sample file open with several tested specimens. You can see I have a results table, operator inputs, and the raw data viewer configured. Users can configure Bluehill to determine what, how, and when data is exported. By going into the Method tab under Exports, users can configure the export settings for reports and general data export. Under the File Settings section, users also have the ability to set a default folder. The selected default folder can be saved within individual methods, and this is where all export information will always be saved. Users can specify a name for the sample file, as well as choose to append the sample file with a date and time stamp. Users can also create 2 separate export files. This can be helpful when 2 different export formats or export information is required. Under the Setup tab, within the Export File tab, this is where users have the flexibility to determine the content of the export by using the toggles here. The export preview is an easy way to visualize what your final export file will look like. Also, within the Setup tab, users determine when the export should occur, such as at finish, on demand, or after each test. In addition, users can specify the export behavior, preventing an operator from overwriting previous data. Finally, Bluehill can be configured to automatically initiate an external program. This is beneficial for users who want to pull Bluehill data into their database or LIMS system. Under the Format tab, users can specify the output file format. While the default file is a CSV file, users have the ability to create a custom text file to allow for complete customization and seamless integration with a database or LIMS system. If desired, under Method Parameters, users can add non-results-based information associated with the method, such as test rate and preload value. Moving back to Setup by toggling the Method Parameters option, users will add their selections to the export for each specimen. Moving back to the Test tab by selecting Finish, Bluehill will export the data as it was configured. Now we can browse to the export location and view our data export.
Now I'll talk about two other features that can help increase throughput and/or minimize retesting. On our new 3400 and 6800 testing frames, you have the option to save your testing grip pressure in the method. Thanks to the Smart Close Air Kit, you no longer need to adjust the pressure at the regulator itself. Customers who change the pressure from sample to sample love that it automatically saves in the method and that they can use choice inputs to change the pressure based on a specimen type selected. This saves time by avoiding adjustments at the regulator and reduces the number of specimens that need to be retested if the pressure was accidentally adjusted incorrectly. Finally, we have audio prompts. This can be set up to alert an operator that it is time to remove an extensometer or that the test has ended. This is especially beneficial for operators that are multitasking, like running several machines at a time, and can use an audio reminder to keep the testing running. In summary, there are several options to consider if you are trying to optimize your testing procedure. Some you may even have now but just weren't aware of, like the software changes we discussed or integrated specimen measurements. Most micrometers come with a cable, it just needs to be plugged in and set up. Looking at this cost versus impact graph, there are smaller improvements you can make to your system, such as upgrading to pneumatic grips with specimen stops, or investing in an automatic extensometer that will result both in time savings, but also in increased repeatability. The multi-station testing system is a great solution for laboratories that need a high throughput. Like I said earlier, they can be configured with up to 5 load strings, enabling a user to run 5 specimens at a time. When thinking about your total test time, this can make a huge impact. Next is the AT3, which is our non-robotic automatic solution, which has the ability to test ISO and ASTM standards in tensile and bend. For labs running 24/7, a fully automated system, where the human error is taken out of the equation, can result in dramatically increased throughput and provide very consistent results. As you can see, many of the features that I talked about will dramatically help increase efficiency while also providing more consistent results. Beyond what I talked about today, there are many different ways to improve these two parameters for the material or component that you may be testing. So don't hesitate to reach out if you think that these solutions are not applicable to you. We understand that there are many unique testing solutions, and we love to work with customers like that. At this time, I'll turn it over to one of our applications engineers, Dan Caesar, for questions. Thank you for your time.
All right, thank you, Kayla. So a good amount of questions has come in during the past 20 minutes, and then also leading up to today during the webinar's registration. So some of those questions entered at the registration were definitely covered in the slides that Kayla just went through. So I'll consider those answered. But now I will address 5 to 10 questions, depending on time, that weren't covered and that are relevant to the topics of throughput and variation. So let's get this Q&A started. All right, so our first question is how to reduce variation in results when using shear compression tests on fragile samples. So fragile in torsion specifically. So the answer for this is that alignment is crucial for any type of shear test, whether you're talking about tension or compression. Standard grips and fixtures are designed to keep forces in the center axis of a load cell. And the standard grips and fixtures, they anticipate a symmetrical specimen geometry. So generally speaking, shear specimens can throw this alignment out of whack. So fixturing designed specifically for the particular shear test is very important for reducing variation. Instron does offer dozens of different shear fixtures for both tension and compression. Many of them are specifically in compliance with ASTM or ISO test standards. So particularly for this customer, I would recommend for you to check to see if the test you're performing is specific to a standard. And if so, let us know and we can find if we have a fixture available for that standard. And if not, we can have our custom solutions team take a look and provide a quote for any necessary fixturing. So our second question is, sometimes the specimens break outside of extensometer area or at the grip. Are these measurements acceptable? We are noticing higher variation in some results with these specimens. So the answer to this is that depending on the material that you're testing, breaks outside the extensometers knife edges can be common. So particularly when you're testing plastics and metals, that localized necking can occur. And if you don't know what localized necking is, it's essentially when a specimen is thinning in a particular region rather than deforming uniformly along its parallel region. So it is okay that this type of plastic deformation occurs, but it's not okay that you're using an extensometer to measure strain for this region of the test. So that's simply because the extensometer is completely blind to the strain that is actually occurring. So for materials that experience this localized necking, we recommend switching the strain source from your extensometer to crosshead position after yield occurs. So when you enter the plastic deformation region of your test. And this change, it occurs automatically and within a single measurement called tensile strain in Bluehill Universal software. So the user simply needs to specify an appropriate removal point for your extensometer. Also involved here, I'd recommend that you should read your test standard, because plastics test standards such as D638, they actually state that for materials that exhibit localized necking, that your strain at break calculation should be, or shall be, whichever it is, it should be calculated as nominal strain, which uses the crosshead position and the original grip separation to calculate strain for that very reason. All right, on to our next question. So here we have, our testing requires a temperature chamber, which slows down our throughput. How can we make improvements to our testing efficiency, specifically related to the use of the chamber? So certainly non-ambient testing can hinder a lab's throughput, but there are a few ways that a lab can mitigate this bottleneck. So as for hardware, we offer pneumatic high temperature grips up to a 10 kilonewton capacity that allows for fast specimen insertion compared to a manual equivalent. And so with these pneumatics, you're reducing the time that the door of the chamber is actually open. So not only is it faster to clamp the sample, but the door is open for less time, you're losing less heat, and the actual ramp back up to the test temperature is going to be reduced. And as for software, Bluehill's pre-test controls allows chamber users to automatically start the test after a specified temperature and soak time is reached. So this allows the operator to focus on other tasks rather than just waiting for the temperature to cross 100 C or whatever it is and pressing start. That can be done automatically and they can focus on other things. And finally, relevant here is the onboard controller for our chambers, that the temperature ramp controls can be adjusted to either be faster if you want to speed testing up, or slower if you're experiencing some sort of overshoot of the temperature. So these settings can kind of be difficult to change if you're just trying to self-diagnose and just press buttons on the onboard controller on the chamber. So I would recommend finding and reading the manual that came with the chamber for these instructions. And if you can't find that, just reach out and we can provide that manual. Our next question is, how do I know if my specimens are prepared properly? I suspect our inexperience might be affecting our results. So the answer here is the quality of specimen preparation is definitely another factor that can affect a lab's variation, and many of the things that Kayla just covered won't fix the problem if the underlying issue is the fact that your specimens have poor preparation. So whether you are testing in compliance to an ASTM or ISO standard or not, I would highly recommend reading the test specimens section within the most relevant standard for guidance of acceptable tolerances for your specimen dimensions. So it'll call out the thickness must be plus or minus 0.01 millimeters or something like that for all of the dimensions. And if you're within those tolerances, then your lab really shouldn't have to worry that the preparation is causing any sort of inflated variation. All right, our next question is, our lab is testing the same material as another lab within our company, but we are getting different results. How do we know whose results are correct? So this is a question that really comes up a lot for specifically my team as an apps engineer. And unfortunately, there really isn't a good answer that we can point to. To properly troubleshoot this circumstance, both labs need to outline their test setup and any differences, no matter how small they might seem. All of this needs to be noted. So the test frame, its manufacturer, its load cell, the grips, the jaw faces, any type of extensometry that's being used, and then on the software side, so the test method, so the programmed preload, the test speeds, any calculation types, all of this needs to be considered, as any one of these variables could be the source of the discrepancy that you're seeing between the labs. So after identifying each lab's complete test setup, I'd recommend first just unify a single method within the software that each lab is going to use. And then from there, if your results are still different using the same test method, then you've isolated it to being, okay, so it's one of your fixtures or something on your test frame, or it could be your operator's interaction with the test frame that's creating this difference. So I would say work from there to further unify the entire test procedure until the results close in on each other. So this can be a slow, methodical process, but in our experience, it's really the only technique that we've seen customers use and use successfully. All right, our next question. Other functions within our production use barcodes to enter information. Can we scan barcodes within Bluehill? So this is a simple answer, yes, definitely. Bluehill Universal can receive text inputs from barcodes. The setup is very easy as long as the USB barcode scanner that you're using is a USB input to your Instron computer. So it's going to be simply plug and play. There's no complex setup within Bluehill. You plug it in and it should work. So rather than typing manually the information that would be on the barcode's information will scan into that active field into Bluehill. So this definitely can save time. And as Kayla had mentioned about choice inputs earlier, that it also will prevent any typos from happening, which can have some bad downstream effects. Another question, could you discuss using automation such as robotics on universal testers? So Kayla briefly did talk about how automation can provide improvements to both the lab's throughput and their undesirable or variation in their results. And actually, to expand on what Instron offers in terms of automation, we are actually hosting a automation webinar next month. The registration hasn't opened up yet, but it's going to open up soon. So if you are interested, make sure to keep an eye out for that and sign up when it does open up. All right, I think we're going to be able to do a few more questions here. So another is prompted test workflow standard in Bluehill, or is it an added cost? So one of the features that Kayla had gone through is our prompted test workflow, and it is standard to our Bluehill Universal software. So there's no additional cost. It comes with the package. And this is also true for other features you saw. So the exporting features, PassFail, setup, the use of the ASMD, that those are all standard features within Bluehill Universal. Another question, are the automatic alignment stops only attachable to automatic and or pneumatic grips? So the answer to this is that the alignment stops will attach to our newer style manual side action grips, as well as our manual wedge grips. So depending on how old your grip is, you just want to let us know, because you may or may not have the ability to use the standard alignment stops. So our next question is, in the exports tab, what is the difference between file 1 and file 2? So the difference between file 1 and file 2 is how you set it up. So you have the ability to configure 2 different exports. So some labs might require different file formats, or some labs might want to only include the raw data in one file, but then have the results in a different file. Or maybe a lab wants to have it all in a single file. So we just have the flexibility to do whatever you need to do. And then our final question I think we're going to address today is, when is the correct time to balance your load cell? Should the top grip be tightened and then the load cell zeroed? Would it be incorrect to balance load cell right after the sample is tightened on both grips? So the answer to this is that you definitely shouldn't zero a load cell when both of the grips are tightened, because if you think about it, you're closing on your sample and that there actually is a load present when both grips are closed. So now you're going to balance that out, and you're balancing out true load that's on the sample. So instead of zeroing at that point, we recommend the use of Specimen Protect. Specimen Protect is available on our higher tier frames, so our 6800 systems. And what it does is, even with both grips closed, it's monitoring the load on the system, and it's moving the crosshead very small distances to make sure that when you are clamping on both sides of your sample, that it's not seeing a particular load. And if you're not using Specimen Protect, then we recommend to use a preload, and that's going to be in your pretest settings of in your method tab, to quote unquote get rid of this force. So really the correct time to balance your load cell is when the sample is not installed. So I think with that, that's going to do it today for our live Q&A. So I apologize to anyone whose questions weren't answered, but we'll definitely make sure to reach out to those individuals that had questions just as we were moving along here, that are relevant to this topic. So again, thank you for your time and attention. And with that, Nick, I think, can you help us close out?
Yep, thanks, Dan. So that is going to do it for today, but I do want to just throw a couple quick notes out there before we all head out. The compliance correction paper that Kayla mentioned is available in the download kind of handout section. So if you do want that, you should be able to download it right now. Today's recording is going to be on YouTube in just a short while. And then we're also going to email a copy of the recording and the slide deck. So all of you will get copies of that. Next week, Ian McIntaggart, our composite testing guru, is going to return for another webinar on composite laminate testing. This time, his entire session is going to be dedicated to audience Q&A. I know that was something that a lot of people were very interested in doing last time around when he spoke. So he's one of the leading composite testing experts in the industry. So if you are involved in that kind of realm, you won't want to miss this. You can find us a link to sign up now on instron.com. With that said, I just want to thank Kayla for joining us today. Thanks a lot. You did a great job. Dan, thanks for handling questions. I know we got a bunch. We love getting questions. And again, we will follow up with people that sent in questions that we didn't address during the webinar. And thank you all for attending. I know it's a beautiful day here in New England area. So definitely appreciate you being here. Stay healthy, everyone. I hope to see everyone again next week.